All right, welcome back. We are Game 3001. That's Artificial Intelligence for Games in the winter 2022 semester at George Brown, and it's week 14, part 2 of our broadcast and recording. And what we're doing this week for our lab is we're going to follow up on some of the things that we've talked about already. For what we stated was we're going to add more actions, which is kind of vague, but let's talk about it. What we're going to start is up on Blackboard, what Alex has done for us. And by the way, that I am already sharing this video. For what Alex has done for us is, again, he's given us in our labs, under labs, if I scroll down to lab 8 here, you can see that there is a few things we need to download: Torpedo K PNG and Torpedo K OG, as well as some steps. And what I've done to prep for this one is I've got a Lab 8 sandbox that I used. Here it is. And I'm going to use this Lab 8 sandbox to drag and drop these or copy paste these into my a copy of Lab 7, which I'm going to work with for your section. So again, I'm going to go to desktop. I'm going to go to GBC 3001, section 400, which is you guys. And inside of there, I have Lab 7.3, which I'm just going to copy paste. So just do one of these, copy paste, and we're good to go. It's going to take a second for this to happen. And when it does, then you're going to see that we're going to copy stuff in there. Okay, so there's a bit of code there, but that's okay. We're going to change this to Lab 8. And inside of Lab 8, we're going to kind of go into the assets folder. First, I'll go into the audio folder and I'll copy paste my Torpedo K OG that you can download from Blackboard. And I'm also going to grab my Torpedo K.png. I'm going to put that in sprites because that's what this is. If I take Torpedo K.png, put it in there, and if I double click on that, you're going to see that the sprite is exactly like the other torpedo, except for it's green because now it's the Klingons firing, right? So we're going to have a green torpedo instead of a kind of the yellowish torpedo that you saw before, or the red. So that's the torpedo that we're going to use. So it's exactly the same one. Alex has just changed the coloration so it's green tinted, and that's fine. So we can use the same torpedo.txt file as a data file, which is the exact same thing for both sprite sheets. So two different sprite sheets, same data file. All right, so that's what we're doing there. So now that we've copied everything across, we can go and actually start the lab. So again, I'm going to go into my desktop and where I have my lab and going to Lab 8 here and double click. So just to get that going. Okay, there we go. So there's Lab 8. And for you guys, I think we're using, I'm just going to shut all these things down for a second. Let's go and shut them down. Close all tabs. And we'll also shut these down just because, you know, we want to start off with fresh. Nice. And we'll also run this thing and see what we've got going on right now. Oh, this is not what I wanted. This is the new one. How is that possible? How is that possible? I must have clicked on the wrong one. That's okay. 401. You guys are 400. Aha. That's what I wanted to click on. 400, not 401. But you notice that the actual ship will change to a Klingon. That's going to happen soon. Let's close all these down. Close down all of them. And we want to close these ones to start off. And we want to always run the lab to make sure that it runs from the previous version. So if I made a copy paste before you start, because this can cause some problems, you know, when we're like, I don't know why, but this thing doesn't work. Well, what if it never worked? What if you copied something over or something failed to copy and it's just not working? So I always try and rebuild everything before we start. And I think it's a good plan overall because we can get into some trouble. So Alex was quite kind in the stuff that he put together for us, which I'm happy to say worked very, very quickly and easily this morning when I was with him in his lab. And so this is where we start off. You can see that is how it is. And notice that right now it says performing move to line of sight action because The reason why it's saying this for us is because if we pull over IMGUI, you can see that there is a line that's being drawn from the spaceship to the target, and it's red. Red means that there's no line of sight, but the line indicates what is the radius. This is the radius that the ship has. So the target is clearly within radius, which means that the enemy is going to perform a move to line of sight action. That's what's going to happen. So we can simulate this. And if you notice, if I move the enemy on the x-axis, if I move it within line of sight, just move it across this cloud here. And once it becomes green, right, then you can see that now it'll be performing its attack action. That's what's going to be happening. So this is where it would attack. And we can talk about how this is going to be done. Okay. All right. So that is the what we have right now, and we want to modify what we have. Let's put this up on GitHub. I think this is a good starting spot. And again, I'm going to use GitHub Desktop. Alex was joking around, and I was saying I hate GitHub Desktop, right? I don't really hate it. It's just, you know what? I think there's other tools out there that do very similar things. And I'm someone who likes to use the command line a lot. Actually, I'm a proponent of the command line. But again, it's, I don't mind. This is it's not too terrible. So you can see that these are all the assets that have been added in. I'm going to say added project files for lab 8. That's what they are. Commit to main. And after this has all been committed, we can push it up. Now, I wish, just like Alex was saying today in this morning's lab, he was talking about, wouldn't it be cool if we have our Team Explorer? I miss Team Explorer too, to be honest with you. I really do. And, the challenge with Team Explorer is it doesn't see the only way this works is if Team Explorer sees a GitHub repository that's available for this particular lab. And you can see that clearly there is one. So if I go to Git changes, it'll show you any Git changes that are happening. So here's where this is. And this is with GitHub Desktop, right? So it'll still show everything. We can actually use Team Explorer because it's identifying the GitHub repository right here. So this is the GitHub repository, labs for section 400, right? And as long as we're using GitHub Desktop and not, if we set it up for the first time or we didn't set it up with Gitkraken, then you should be still able to use this altogether, right? So that is something that we can try using later on today and see if it works, okay? But on that, now that we've made a push, and here's GitHub Desktop, you can see that we've made a push. Let's go to the next step in Alex's plan. Alex has kind of given us his steps right here. And if you notice here, the first part is let's start off and make a first commit with all of our lab items. And one of the objectives of this class, we talked about this today, is we talked about how we're going to be focusing on polymorphism and inheritance and polymorphism, and how some of you are having issues understanding inheritance and polymorphism and how to use it and all that kind of stuff. We also had a discussion earlier, just to fill everybody in with the discussion we had this morning's lab at 8 o'clock in the morning, where a student asked, I think it was Jack. He asked basically, hey, listen, there's in the industry we're moving away from using inheritance and polymorphism. Why, Tom and Alex, why are you teaching us this stuff if the industry doesn't use inheritance and polymorphism so much? Well, the answer to that question is always that for you guys, it's important for you to know a wide range of skills. You don't know where you're going to land after your time at George Brown, right? Hopefully you will land in a programming job in the game industry, but what if in the future you don't? It's good to have a broad range of knowledge, good skills, so you understand a lot of different techniques. And one of the techniques that's very common in the software development industry or engineering is inheritance. You need to understand inheritance, or OOP, right? Object-oriented programming, as well as things like design patterns that we're going to be talking about over the next a couple of years now at George Brown. We're going to be talking about more design patterns. You've seen some of them this semester, which is like the singleton design pattern. And we're going to be talking about more of them as we go forward. So remember the problem with OOP, and that they talk about this is, and if I was going to draw this out for you guys, let's use a kind of a drawing program for this. So we'll do that. In OOP, the biggest problem is the inheritance chain or the hierarchy, right? So when we start off here, we have a superclass. So this would be the superclass, right? And in the superclass or base class, some people also call it the base class. Let's put that in there too, just to highlight that. Here's the base class or superclass. It's pretty small. It could be pretty small base class or superclass, right? And what happens is over time, we have objects that inherit from this base class. So let's suppose, I'm just going to make a straight line here. And let's suppose there's just like a one-to-one thing. So we have another class that inherits from this class. And let's draw a weird arrow. And I'm going to make another class that's here. And this is the child class or a derived class. Notice that I made it bigger because this is one of the issues. So this is a child class, right? Or a derived class, also called the same thing, right? A superclass or base class or a parent class is the same thing as saying a child class or a derived class, or a subclass. That's another one that we can use, subclass. These are all the same names, right? That we can put there. Any of these things, it means that we inherit. This line is an inheritance line, and we can say that it has two things. It has an is-a relationship. All right, that's the one thing about OOP that we have. Again, this is just a review about OOP. It has an is-a relationship, and it also, we can say it inherits. And we'll say everything, right? And I mean that because anything that's inside the parent class or the subclass or the superclass or the base class is inherited by this class right here, everything, right? And the problem with that idea is if we continue, right? What if I continue going down the line, right? So let's say, for example, I go even further down. Let's make a shorter line this time because we don't have a lot of space here. Well, let's suppose I make another subclass of this subclass, right? So we kind of have a bigger subclass. We're going to make it a bigger box. And you can see that this one has the same information. It still does all this. It still has an is-a relationship with this one. This is a child of this superclass. In fact, some people like to call this the grandfather class or the grandparent. But really, it doesn't matter. It's an inheritance chain. And this one down here is more specialized, even more specialized, right? Because every subclass is a more specialized version of the superclass. The superclass is a general class, and we keep on specializing, adding more specializations, more features, more features than the parent class. That's what we want to do, right? Because the child class will have more features than the parent class because you want to have some specialization. So even more specialized, and you keep on going down the line, and there's bigger and bigger classes. Where this problem breaks down in a game is if I have a game object, all right, and I keep on doing this stuff. And by the way, we have this problem already, and I want to mention it to you because I don't know if you've noticed, but if I go to let's take a look what we've got here in our class right now. So this is the thing that's happening. If I go, I'm not going to say it's a problem for us because we have a very small game, but let's suppose if I look at a couple of things that we have here. We have our close combat enemy, we have our actions, we have a bunch of stuff that's in here. We have our core, and inside of our core we have a decision tree and agents, and we also have our core up here. And in our core up here we can have again navigation objects and all this kind of stuff, right? But we also have this thing called path node, right? We have this thing called path node, and path nodes, which happen to be game objects, which is what we're using actually in our class right now. Take a look at path node for a second. Open that up. Go to game objects, filter, and look at path node. And in our path node, you can see that path node derives from, this is the colon, derives from a public game agent. Okay. Let's right click on agent and go to definition. Go to definition for agent, please. An agent inherits from navigation object. Okay, that's the second thing in the inheritance chain. And navigation object inherits from display object, and a display object inherits from game object. And game object inherits from, go to definition. That's the top of the chain. So look at that chain: path node, agent, navigation object, display object, game object. Whoop, right? That means that all of this stuff is inside of display object. All of this stuff is inside navigation object. All of this stuff is inside of agent. All of this stuff is inside of path node. So path node is actually a very fat class. It's a very fat class. It's full of stuff that gives us a lot of information. All right, a lot of stuff that gives information. But the problem with that is that that we have, I don't know who's calling me at this point, but we have a lot of information in here, right? And this information that we have is, again, if you think about it, is maybe too much for what we need, right? It's good for us from an assignment perspective because it's easy for us to add in more functionality. That's what we've done for you. We've added more functionality in the path node class in order for it to give us line of sight. As an example, there's a lot of things in the path node class we want to use. For example, in the path node.cpp class, just to give you an example of this, if you go through here, it has a lot of stuff that we want. Line of sight color, line of sight. It has line of sight. We can draw if it has line of sight or not, which is what we want the path node to do. Look, this is what it does. If the path node has line of sight, then it draws different colors, so we actually can see it on the scene. But path nodes, like we mentioned in our lecture this week, also can have additional data. For example, is it a good cover node? Is it a good place to to snipe at the target? A bunch of different things like that. You can put whatever you want inside of any of the classes, and you can have additional data for each of the path nodes. For example, what about each of the path nodes' neighbors? You can start doing neighbor mapping. Or I want, just like we did with our A-star pathfinding, right, where I want to map each of the adjacent neighbors to the path node. Let me show you what I'm talking about here. So when we run the code, and again, I know this is a bit of a preamble, but I need to do this for you guys because I need to explain why, the whys, which is very important. You have all these nodes here, but none of them know about any other nodes, right? And what about if you want this ship to move towards this ship, move to? How do you do that, right? You can't go through the obstacle. That's not allowed, right? In your assignment 4, going through an obstacle is something that we've asked you not to do. You can't move through an obstacle, right? So, but this class will. And a good example of that is if I move my ship or my target. Let's move my target closer, right? Watch this, what happens. If I move my target closer or farther off, right? Let's move my target down here, my ship. What's going to happen to this thing? It's going to start moving, right? It's going to patrol. And eventually what it'll do is it'll try and move through, if you let it, it'll move right through the obstacle, no problem, right? It doesn't know anything about not moving through the obstacles. It doesn't know anything about what the obstacles are. We've given you some tools to stop that from happening. Alex has talked about this obstacle buffer here, where you can actually increase the obstacle buffer to make it more realistic so that you don't hit the obstacles. These are things that you can use as tools for your assignment 4. Maybe it's so that the spaceship or the enemy cannot move through any area that's not being shown, any of the obstacles that are disabled, or any of the path nodes that are disabled. So path nodes that are drawn, maybe if they're not being drawn, they're disabled. If they're disabled, then you can't move through them. And if you can't move through them, you got to move around them. How do you do that? With pathfinding, right? Or maybe you want to target things. You want to use steering behaviors. That's okay too. I want to steer towards the closest node that I can see, right? That has line of sight, which would be this one, right? So let's move my ship manually. I want to move him across here and down to where he has line of sight right here. Let's say, right? There it is. Let's say it was this node, and let's target him. Let's move him so he points at the ship. These are all things that you're going to want to do, right? So take a look at the actions. It says, make the attack action. This is where a good location for this particular thing to make the attack action against your target. Okay, that's why path nodes are important. Their path nodes are important, but they're huge. They're massive, right? So in the industry, we don't use this kind of stuff as much. This is inheritance, but we want to use something like composition, where we kind of add more objects to these classes as well. So inheritance, composition versus inheritance. And we want to say composition over inheritance as much as possible to avoid this part. Well, if we start using composition, we can think of components, right? Once we think of components, there's another thing that's being used in the industry called an entity component system, or an ECS. An ECS, the way it works in our is that you have a entities, which is basically, let's just draw them out, which is just an ID. Okay, usually entities just have a handle or an ID. So this is an entity, all right? And the entity just doesn't inherit from anything else, right? It has some features. One of them is it has the ability to add component, right? It has the ability to remove component, and it has the ability to get component, all right? And let's suppose there's other ones too. Okay, this is what entities might have. They also have a handle, some kind of ID, as an example. And I'm just really simplifying here, guys. Maybe they also have a component list. Maybe that's something else that I forgot. A component list or some kind of vector, a list of components, which is maybe a map, right, of components. That's what it is. And this component map, if you will, is a list of components that's been attached to the entity, right? And then what I have instead is I have a bunch of these components. Let's draw the component out. So here's components. And you might have a component superclass or an interface, right? And this component can be a bunch of there's different kinds of components that you can use. One of them might be something like the transform component, right? The transform component would be something that you want to attach to the entity. So you don't have an entity, you don't build an entity completely. You attach, you kind of construct an entity just like we do a decision tree, right? Where we add a component, add the transform component onto that, right? That's what we're going to do. So we make a component, we add it on as an example, and then this component, this transform component, is part of the entity, right? And you can add other components too, right? Let's suppose we have other components we want to add, right? So we have another component, and let's say that's a rigid body component, right? So that rigid body component is also added in, right? So how do I reference these components when I add them in? Well, they're part of the component list map. So I can do something like get component, where I check the map to see if the component exists, and I return the component. If the component doesn't exist, I return false or null, however you want to do it, right? And so this is a very simple way of, if I was going to do something like this with you guys, that we can have some kind of component system that reduces some of this, right? Now, there's going to be some duplication, guys, right? For example, if I have a spaceship, it's going to have a transform and a rigid body. That's where you can do inheritance. I want to say, well, I'm going to make some kind of object that has these components in it already. Why would I want to map this manually myself, right? Because it has these components, right? And so you can add a combination of things. You don't have to go with one thing or the other. But the entity component system is structured in that it's functional programming. It's using composition over inheritance. And we also have another component we haven't talked about in the system called the system. The system, what it does is it manages all the entities, as an example, in the scene, right? And entities could be, the scene itself could be an entity, right? And the system, what it does is it updates components, all the components and all entities in the scene at the same time, right? And the great thing about this is all the transforms get updated, right? All the physics rigid bodies get updated, right? And they have their own update cycle, which is kind of really cool. From a memory management perspective, this is a much leaner way of doing things when it comes to creating game objects and so on compared to this method. This is the method we're using right now. This method here, where you have components that attach to an entity, as an example, is a much leaner way of doing things than this way. All right, so should you know only this one? No. Should you know only this kind of thing? No. You should know both. You should know other patterns as well. And that's why we're going to talk about inheritance in more detail a little bit today when it comes to our, and one of the challenges that you have as well is for you to, to talk about, or kind of figure out how to do inheritance with your your torpedo class, which is what Alex has asked you to do. I think it's a great little exercise, and I encourage you to do it, okay, to get your marks. So let's go back to, now that we've done our preamble, that's what this thing is about. This thing is about making our torpedo class right now, but you're going to see areas where I want you to recognize, and so does Alex, we want you to recognize areas that you could refactor. What areas can we refactor to make this better? Okay. Let's talk about this in a second. So let's go into our structure. And the first thing that Alex has asked us to do, let's just hide all this again. So close all. And let's get into our torpedo. So the torpedo itself is in the, again, it's a game object. So if we look at torpedo, this is the torpedo right here. We want to duplicate this, and I'm going to do that inside of the operating system. It's just faster. So let's open that up. So I'm going to go to template, and I'm going to open the template up in the operating system again. There it is. I want to go into the SRC folder, and at the bottom where I see my torpedo.cpp and torpedo.h, I just want to copy paste them, please. So copy paste, and now I have copies. Let's rename them Torpedo K, which is where I want to go with this. So here's Torpedo K, and there is Torpedo K. There we go. And then we want to import these into the actual project. So let's do that. So inside of our in our game objects where we have our torpedo, I want to right click and I want to add existing item. And then what I want to do here is I want to swim to the SRC folder, scroll down to where I have my torpedo Ks, those two, and then add them in. Now they're the exact same thing as the torpedo right now, and we don't want that. We want them to be separate. But tell me what we could do. What are the similarities and what are the differences afterwards? Okay, so first thing first, let's rename the stuff that's inside here. We want to rename this to Torpedo K. Okay. This should also be renamed to Torpedo K. I'm just going to do it manually. There's not a lot to change. So let's change all these to Torpedo K. So that's the first thing, first part of the class, is we're changing the name of the actual class itself so it doesn't clash with what we have. And also up here, this should probably be named Torpedo K, right? So that way we know this is our type guard. So that way we know that we're not going to kind of add duplicate torpedoes or a duplicate thing. We're not going to reference this more than once. All right, so that's the first thing. We changed all this, and you know what? I forgot last week. It looks like I had not changed this comment. We'll change it here, right, for this one. And let's change our CPP as well. So then now that the K is changed, let's change that Torpedo K file right here. This is what it's going to be changed to. Notice as soon as I do that, that these all change. Well, now we can do some copy pasting, right? And maybe a smart thing to do is not change this yet. But to actually change this part by copy pasting in, we'll do a Control F to find all torpedo references. We'll also make sure that you've checked on match case, and we're going to go here and change it to Torpedo K. Look, it even remembered that I did that already, right? And what we can do is we can go to the next one. So we're going to move to the next one or the previous one if you want to, right? And we can change all the ones that we want. So again, we want to start here, right? And then when we do that, we want to change only the ones that we want to do. So let's change that one. And we can go and change all of them one thing at a time, right? And as we go forward and we change them to Torpedo K, right, you can see that it's going to start asking us for changes, right? And I want to skip over this one to go to that one. So this is Torpedo K. It's asking us to include it. I'm going to include it in a second. Go to the next one. And now we're back up at the top, and we're going to change this one too to Torpedo K. And now it should find our files. But this one also should be changed to Torpedo K. That's the constructor, right? And I think we've got most of them. And if we missed something, that's okay. We can put it back in, and that's how I would do it. Anyways, however you end up doing them, change them all to Torpedo K. So all the torpedoes should be changed. So that's the first thing we're going to do. Next, we know that the torpedo PNG file has changed to torpedo underscore K, right? That is what it's going to be changed to. Let's also rename the sprite sheet. So it's Torpedo K sheet. I made a mistake earlier. Copy paste this, guys, to reduce finger typing errors. So copy paste into here. And also down in here when we're drawing, that's something we want to make sure we have correct. And earlier today when I tried this out, I was like, how come it's not drawing? Because I typed it wrong. And that's kind of a negative of using a map, right? So torpedo K, that's what that looks like. And save. So now we've changed our files. We need to make additional changes here because what we want to do with the torpedo, and we want to give it a few more, some differences compared to the regular torpedo. So torpedo K, which is our Klingon torpedo, let's go back to our H file, right? And previously with torpedo K or the original torpedo, it had just a speed. And why was that? Because our target was firing the torpedo. We just wanted to give it a speed. It would fire straight ahead. Okay. But now what we want is the Klingon torpedo to have a target. So let's add the target here. So we're going to say it's going to have a new GLM vec2 direction that it's going to go in. And we can initialize that direction as well in different ways. We can say it's a GLM vec2. That's one way of doing it. And Alex has actually recommended the object notation, which is fine too. We can go 0, 0. That's also good. Okay, so that kind of initializer gives us a default value for direction and a default value for speed. It's kind of an initialization value. Cool, I like it. But now we don't need this. We don't need speed anymore, so let's get rid of it. And instead of speed, we need to kind of store inside of our class as a data member m underscore direction. We want the direction that we pass in from the constructor function. Okay, that's what we want. All right, save this. And let's go back into our torpedo.k.cpp now after we've changed the constructor function and added a data member. And let's go over here and see what happens. So in the constructor function, it's no longer valid because it's missing a member. Let's put that back in. We'll say we need a GLM vec2 object, which we call direction. That's what we need. And that satisfies the requirement of the constructor function. We're going to pull this down over here. Okay. And we don't care about speed anymore. All right. That's not what we care about, but we do care about direction. And what we can do with that is, down in here underneath the projectile area, we can initialize the direction as well. So we can say that m underscore direction, well, that's equal to whatever the direction currently is, right? Let's say direction.y multiplied by speed and direction.y multiplied by speed. Okay. If I can actually type direction, that would be great. Can't usually type. All right, so that's the way it is. So what is the direction? If we think about what this is, what is the direction? Direction is the if I take a start and an end, two points, two vectors, a start point and an end point. Let's draw this out. Let's go back to our little diagram that we used. This is this. Let's just clear this up. We don't need this anymore. And let's suppose I want to get direction. Okay, so this is our map, right? So here's our map. And we want to have a direction from A to B. So this is point A. And this is point B, let's say. A to B. Then how do I get direction from A to B? Well, I take B, right? I do this formula. I say, well, the direction, right? I can start off by saying, well, that's just like vector B minus A. But if I do vector B minus A, if I did this, right? If this was the formula I was using for direction, then I would get a whole line, because it basically subtracts vectors. If I subtract this vector from this vector, and we kind of use the origin, which is 0, 0 as the original as the vector origin, then we remove the origin and we draw a line that goes like this. That's what we got. We draw this big line, because remember, a vector has two properties. It has a vector has both magnitude and direction, right? Those are the two things a vector has, right? That's the property of all vectors, right? So because it has magnitude and direction, we don't need this whole magnitude. We need another type of magnitude. What type of magnitude will we need? if I only care about direction, what do I need? Guys, do I need this whole line? Because imagine if I was to use this whole line to move, I would like be shooting through the page, right? Really, really fast. If I took this line and multiply it by speed, I would be like moving, I would shoot through this entire area. So what do I really need here? Do I need this whole magnitude? What are your thoughts? The answer is I don't, right? I don't need this whole magnitude. Let's undo that change. And what I don't need is that I need another formula. I want that the direction is equal to the normalized version of b minus a. That's what I want. And what this kind of gives us is the unit vector. I typed in unit vector, okay? And the unit vector, which equals to a magnitude of 1. That's what it gives us. That's what we want. We want a magnitude of 1. A magnitude of 1 is like, it's a smaller vector that's pointing the same direction that we want to go. So it's kind of, if I was going to draw something like that out between this point and this point, it would look like something like this, like really small. Okay, so really small line, something like that. Okay, and that is the unit that we want. That's the unit vector. Okay, we don't want the whole line. We just want a pointer, like literally something that's pointing in that direction. And then we can multiply it by speed in order for us to get there. So that's the direction that we want to go in. Going back to this then, that is why we're getting this. This is going to be, maybe if I did this correctly, not the way, maybe the way Alex did it and not this funny way that I was trying to do it. Here we go. Then we can initialize direction. And that's what this direction is all about. The direction really is, we want this to be a normalized value that we use, to move in the direction that we're going, okay? Even for our torpedo. So torpedo right now, we got the direction, and we also have torpedo K-sheet to draw, but then we come down to this update function, and we have speed. We don't want to do that. Instead, what we want to do is we want to take the position value that we currently have, and then we want to plus equals to m underscore direction. So we want to add the direction, which is kind of a vector that has, again, a unit vector of 1 multiplied by speed, speed being a scalar quantity. That's what this is. This is a scalar. And we're scaling out the direction vector, which is a unit vector, by whatever the speed value is. So scaling, right? And then once we scale that up, we take that new vector that we have, the m direction vector, and we add it to the current position. So position continues to move. We're actually changing the transform every frame. Okay, and that's how the torpedo moves around. And that's really it for the torpedo. The torpedo is pretty much done. Let's put this up on GitHub. So let's try Team Explorer for this time around. So I'm going to go into Team Explorer here, and I want to go to Git Changes, and we see that these are the changes we made. We will make a little commit message. We'll say something like, added torpedo K, right? Commit all, and then we should be able to push. We should. And let's see what happens when we do that. Hey, it worked, right? And we can check that if you want, right? So if we go to our GitHub and we go to George Brown, and you can see that here I have your stuff, and I just updated that, right? So here's Lab 8, and you can see that in Lab 8 I added Torpedo K inside the SRC folder. Okay, so you can see that works, but it only works for stuff that we've used with GitHub Desktop. If we use something like GitKraken, it would not work. So we really don't need this anymore. We can close this down. All right, great. So now that we've added our torpedo, let's continue with our kind of stuff we've added. We added this part, okay? And now we want to mess with our ranged combat enemy. Guys, there's not a lot to do in this lab for us. There is a portion for you to do right here, okay? This is the part that we want you to do. And we'll talk about this as we go to get full marks. So we did the torpedo class. Now we want to change the ranged combat enemy in order for it to be able to fire torpedoes. So let's do that next. back to the drawing board here. Let's go back to Solution Explorer. Let's go into Decision. Let's close down our torpedo. That's been done. And we're going to, what we want to do is go into our Ranged Combat Enemy and pull up the .h and the .cpp. And one thing that we want to think about doing is I want to get a reference in our Ranged Combat Enemy to the scene that I'm going to add the torpedo. And this is where Alex was talking about this morning. So what we want to do is let's add this to the play scene. So imagine if I did something like this. So this is new for Lab 8. We want to include the play scene.h. There's our play scene.h. And let's say I want to, in our Ranged Combat Enemy, I want to not just have an empty constructor, but I also want to be able to take in the scene so that way we can add a torpedo to the scene. Okay, because we have to know how to do it. Like, where am I going to add the torpedo to? If I'm going to add a torpedo at all, I need a scene to add it to. And there's lots of ways to do this. We could make all the scenes singletons. I don't recommend that. I don't think it's a good idea. It's better to have it, done in a different way. And so we might pass the scene across to our Ranged Combat Enemy. Let's do that. So our Ranged Combat Enemy would have a scene reference. And let's suppose I want to type in play scene. So I want to play scene, kind of pointer, and we'll call this M underscore, or just the scene that we want to add in. There we go. And okay, cool. There's our play scene reference. And that's cool. And what about if I wanted to, down over here, I wanted to have a couple of things. So this is also new for Lab 8. I want two things. I want to be able to fire a bullet, which in this case is our torpedo. I want to fire this torpedo with some kind of firing delay. Okay, that's what I want to be able to do. So the firing delay is going to have a couple of components. One of them is going to have the delay time, right? Which would be how long do I want to wait before I fire a torpedo? Now, luckily for us, what we've included here for you guys is if you go to the singletons, and if you look at game.h, game.h actually includes a couple of some utility functions for you to have this. One of them is delta time, and the other one is get frames. So get frames and set frames allows you to get the number of frames that have elapsed since the start of the game. And delta time allows you to use delta time to do things like scale your actions in the update function so that they don't spam the user. Okay, that's why we've added those two things in. They've been here for forever. So we could use get frames. And then what we want to do is we take the number of frames that have elapsed, and then we use some kind of we divide the number of frames by a value. For example, 60. And that means that if the number is divisible by 60, we've moved 60 frames ahead, right? If the number is not divisible by 60, if there's a divisor, then we don't have that. So we can use the get frames function from the game object to scale or to delay that many frames. So what Alex did instead is, which is totally fine as well, is he's added two counters. So one of them is some kind of fire counter, M underscore fire counter. Let's say, as an example, that counts how many frames have gone by. And then he's also got M underscore fire counter max, and that's the frame delay, if you will. Frame delay. Okay, and then he counts number of frames that have elapsed. Okay, and then at the bottom, he's also going to make a reference to the scene. So if I say play scene, M underscore scene is what we're going to use. We're going to store it in M underscore scene. And if we were to do this, do you guys see a problem doing this? So I'm adding play scene, and I'm adding play scene to the Ranged Combat Enemy. Let's fix this problem because Ranged Combat Enemy right now, it's also, it doesn't have a constructor function, right? And we want to make a reference from the play scene to the Ranged Combat Enemy. So how do we do that? Well, in the scene class, let's just quickly change the scene class so it doesn't give us any errors. So if I go to the playscene.cpp, then you're going to notice that there's going to be an error right now because we've modified the Ranged Combat Enemy. And if I want to make a reference between the scene class and the ranged combat enemy, what do I put here then? What do I do? How about for the guys that are here? So we want to make a reference to it. What value do I put in here to make a reference between the scene class, the play scene class, and the ranged combat enemy? I want to give a reference from the scene class, this scene class. I want to say pass a reference to this ranged combat enemy so that the ranged combat enemy knows where to add the torpedoes. Yes, correct, Ethan, this. You put this in there. So once we've got this keyword in there, now it satisfies the constructor requirements for the ranged combat enemy. So ranged combat enemy up here, you can clearly see that it asked for a play scene. We gave it what it asked for. Yay, awesome. Thank you for that, Ethan. So that's good. But my friends, if I just did this and nothing else, I didn't modify the play scene, the ranged combat enemy at all, what if I tried to build it now? And you're going to see that, well, I'm going to get a pile of errors. Why am I going to get errors? I didn't do anything really. All I did was make a reference to the scene class, and I get these like 72 errors, right? A crazy amount of errors in the scene class, 72 errors. Alex actually only got 33. I get even more errors than him, right? A bunch of errors. What the heck? Why did I get all these errors in the scene class, right? How come? And it comes everywhere. Ranged combat enemy, it looks like game object, and a bunch of places, and they're all like some kind of syntax errors, right? Look, it says syntax error identified play scene, syntax error missing a semicolon before the star. What the heck is it talking about? Why am I getting these crazy errors? Why? Why? Anybody? I shouldn't get these crazy errors, right? Because I didn't do much. Can anyone understand why? Here's some hints. Let's take a look at the playscene.h. Playscene.h. Hey, here it is. And I've got the ranged combat enemy I'm including. Okay, so here's what we've done. I'm including the ranged combat enemy, and the ranged combat enemy, right? There we go, Ethan. It causes this, it includes our looping. Yeah, it's called a cyclical reference is what it's called, right? Cyclical reference. Alex had a really cool image of Spider-Man pointing at himself earlier, which is pretty cool. That's kind of what is happening. So the play scene is pointing at the ranged combat enemy, and well, the ranged combat enemy is pointing at the play scene, and what? How can that work? It can't, is the answer. You can't do that, right? There's ways around this. And really, here's another question for you guys. Do you really think we should put in a specific scene for the ranged combat enemy? The ranged combat enemy should be in any scene. Again, if we had 10 scenes, 15 scenes, 20 scenes, and we wanted to use the same template, the same base class, we should be able to use the same base class in many scenes, which means that this is not the answer. Instead of play scene, we should use the scene superclass. If we use the scene superclass here, then we can specify that it's the scene that we want to use. And because, going back to the inheritance chain, because the play scene has an ISA relationship with the scene superclass, we can pass that scene in as a reference, no problem. Let's fix this one too. So it's scene, right? It's the scene itself. And if we just did that change, just that alone, right? And if I ran it the way it is, no changes to the ranged combat enemy, we should have no errors anymore, just from that. So that's cyclical reference. If we're not careful, there's a bunch of errors still, right? That are happening. Okay, let's see what these errors are. This is all new, right? So it says, here's something, ranged combat enemy void overloaded member function not found in the ranged combat enemy. Woohoo, right? And it says agent and game object and blah, blah, blah. Whoa, what happened here? How come we're getting all these craziness? Well, we changed this, but did we actually change the CPP? We did not. So this is something we have to change too. So this is the next, that was where all the other errors came from. So let's put that in there too. So we're going to say we want a scene pointer. That's what we want, a scene pointer. And we're going to call this the scene. And we need to, reference the scene itself. So we're going to say something like here, where I want to do a couple of, kind of initializations. One of them is M underscore, fire counter. Let's set fire counter to 0 to start off. We'll also set M underscore fire counter max. We'll set that up to something like 60. And then finally, we'll set up the scene, M underscore scene, to the whatever scene that we take in. So that should satisfy the requirements now of the things that we didn't have before. Let's try that again, right? So let's run that again. And let's see if it causes us any more errors. Yeah, and now we're good. Yay, right? And we're good to go, and it looks like an NCL. Let's change the NCL. We don't want it to look like an NCL. Let's change it to a D7 small, right? So that's what we want to do here instead, because we want to make it look like a Klingon again. So again, we just changed from Reliant. We changed this value to D7 small, save and launch. And you can see now it's going to look like a Klingon, which is what we want, right? Because the Klingon is going to fire at us. Yeah, that's the one, right? So that looks a little better. And that's all we did. We just changed that part right there. So again, a couple things we did. We had to change the constructor function, but even if we hadn't done this, you will see that there was a cyclical reference. Okay? You shouldn't see an exception anymore after these changes. So again, things I changed for the ranged combat enemy so far. I changed this. I'm including the scene class. I'm making it so the ranged combat enemy constructor takes in a scene pointer. I'm making it so that at the bottom we're storing the scene pointer as M underscore scene. We also have two counters, a fire counter and a fire counter max, that's going to keep track of the frame delay that we're going to use before firing a bullet, which is set within combat range. I'm not sure where that is, Ethan, because we haven't changed anything yet. So you shouldn't get that error. So that is that's the one thing we've changed. So, and then we changed the constructor function so that way it takes in a scene reference, which is a pointer. All right, so now that we've done this, everything is pretty much the same as it was before. We're not changing much of anything here because that's not much changing, right? But what we want to do now is we want to focus on changing the attack method. And you can see that we have in our little thing here, a little map, we can see if I scroll down, I can have flee, move to line of sight, be behind cover. These are all the attack, these are all the actions. There's attack. If I click there, I can take myself to the attack action. And this is where I want to change this piece right here. Did you fix your problem, Ethan? Again, I haven't done anything different. So if that's the only change I want to make right now, what is that change going to look like in the attack action? Well, let's try and figure this out. So we're going to say something like, well, I want to initialize my fire counter. So I'm going to say M underscore fire counter. Well, that's going to be equal to 0. So we're going to reinitialize that to 0. Yay, awesome. And then what I want to say is, okay, cool. When I'm firing, I want to say that if my M underscore fire counter, it will increment that to the next frame. And we'll say M underscore fire counter max, right? If we divide this, let's divide it. We're using a modulus operator. Modulus operator is like division, except that it only returns the remainder. If the remainder is 0, that means that I can divide by the fire counter, divide by 60. Then I can do something where I'm saying something like M underscore P scene, right? I want to take that scene. Did I call it scene? I did. Bad me. That's bad. I'm gonna rename that in a second. I want to take the scene and I want to do something like spawn the enemy torpedo. I want to spawn the enemy torpedo from the scene. That's what I want to do. Let's just rename this M underscore scene to match our requirements for documentation best practices and naming conventions. M underscore P scene. That's what we wanted to change. There we go. So I want to spawn enemy torpedoes, but right now there is no spawn enemy torpedo in our placing, is there? Right? So what I want to do is take this function and add it into our placing as a new function that we're going to use. So let's go back to the placing for a second, because this is how I'm going to do the spawning of the torpedoes. Let's go back into the placing.h. And somewhere inside the public area, let's add that function in. It's going to return void, right? And we're going to spawn enemy torpedo. Yay, there it is. And let's instantiate, or let's add or implement that that function. I'm just going to go here to the top, and I'm just going to generate definitions by declarations, and there it is. All right, so there's my spawn enemy torpedo. Awesome. Okay, but even if I've added it to the scene, I've added it to the placing, if I go back to my ranged combat enemy, it doesn't compute. Why? Because, well, scene is just a generic scene. It has no knowledge of spawn enemy torpedo. Even though we passed in the scene reference, right, from the place scene, we passed it in, right? So when we added in when we instantiated our spaceship, we added in a reference to the scene pointer here, right? We passed it into the ranged combat enemy constructor function, which is, well, here at the top. We pass it in here, so it has a reference to the placing here. But unfortunately, because we're using the superclass, right, we're actually upcasting this thing when we pass it in to the superclass's generic scene class, right? It has no knowledge of all the specializations that our placing has, which by now also includes a spawn enemy torpedo, or spawn the torpedo function. It doesn't know about this. So what we need to do is we need to downcast our data member so that it matches the scene type. And in order for us to do that, we can use, well, let's see if we can use a static cast. And the way static cast goes is you need to put in the angle brackets. You need to put in the type that you want to cast. We want to cast this thing. So we want to cast in the parentheses this thing. And we want to use a type that we want to put in the angle brackets. We want to use the placing type, right? So we want to say, I want to static cast this thing, this placing. It has to be a pointer, right? So static cast the placing, which is now a pointer to the scene, to this type. But let's just, to make sure that this is okay, I want to scroll up here and I want to add a reference to this right here. So we'll say new in lab 8, we'll say and include, which is the placing. Okay, there's the placing that I'm going to add in there just to make sure that there's no issues. There won't be any issues, but I'm just making sure. And sure, we can do this, but it says do not use static cast and downcast from a base to derived class. Use dynamic cast instead. Okay, so we should C# or ReSharper C++ is telling us to use a dynamic cast instead. So let's change that to dynamic cast. Could we use a static cast? Would it give us any errors? Probably not, but ReSharper is kind of using the current standards and it's recommending that we don't. All right, so that is what we need to do. We need to do a dynamic cast. We need to cast our current generic scene, which is what we're storing in there in the m_p scene data member. We're storing only a regular scene, a generic scene, the top level scene. We want to downcast it. Downcasting means we want to make it one of its children and turn it into a play scene, right? And we need to do that by casting. We're going to use casting to do that. And in C#, we can do this with the as operator. In C# we could have done something like my scene, m_p scene, and we can say as something else, whatever that scene is, like as a place scene, right? That's how it looks like in C#, right? Unfortunately, in C++, we need to cast. Actually, it's not unfortunate, it's just very, very specific, right? And we're casting by using dynamic casting in this case, because we're downcasting. All right, cool. So that is what we have to do. And now this should compute. And in fact, this is all we have to do for the ranged combat enemy class. So again, let's recap. Ranged combat enemy. We went to the top. We made a reference to a scene, the generic scene class. So this is the scene superclass. Okay, and then when we had that scene, we changed the range combat enemy to get a scene pointer. Added scene pointer requirement for the constructor. Okay, that's what we said. We need a scene pointer. Cool. We're going to store that scene pointer down here, right? Store scene pointer here. Okay, that's where that scene pointer is going to be, right? Or a scene reference. We also like to call it a reference, right? And then in the RangedCombat.cpp, we initialized the counters that we talked about earlier, as well as the scene pointer, right? And then at the bottom, we modified the attack action. That's what this is. It's the attack action. We modified it so that when the attack action is triggered, which means when we're in range, right, we are going to spawn an enemy torpedo, whatever that happens to be. We haven't defined what this is yet, okay, but we're going to do that. And in order for us to spawn an enemy torpedo in the play scene, we needed to cast our scene pointer to a play scene type. That's what we need to do, okay? Save. Let's put this up on GitHub. Team Explorer, Git changes, and we're going to say commit all, but we need to make a change. These are all the little changes we made. Look at this, right? And we're going to say modified our ranged combat enemy to fire torpedoes. We've modified it, right? Hasn't done it yet, but that's what we've done. Commit all, and then we just push. Yay! That should work. There we go. All right, excellent. So questions around this yet? Are you guys good? So check mark if you're good. Okay, Ethan's good. How about the other guys? I'm also going to check up on YouTube and see if we're okay. There's a couple of people watching on YouTube. Thank you for that. And okay, excellent. All right, so thank you for that feedback. And let's continue. So now that we've got this done, we've finished pretty much with our ranged combat enemy for now. What we need to do is let's go and fix the play scene now. So the play scene needs a couple of additional things too. And again, I'm following along with what he's asked us to do here. We've done the torpedo class. We've done the ranged combat enemy class, right? And we're going to now work on the play scene, okay? So that's what we want to do next. So starting off, let's think about what we want. We want a reference to the new torpedo type. So we're going to say include torpedo.k, this one, torpedo K. All right, and so this is our Klingon torpedoes. Now we have both torpedo types here. Okay, we have our spawn enemy torpedo, which has not been defined. We've just made it, but it's empty. And then we have a vector of regular torpedoes. That's like the Federation type torpedoes. What we want is another one of these, right, which is our Klingon torpedoes. Oh man, when I start doing this, and Alex kind of said it was bad in the earlier lab that we did at 8 o'clock in the morning, and it is bad. Why? Because we're duplicating, right? And we're going to put a little to do here, and then this needs to go, right? We can't have this. This is bad, really bad. Why? Because it's the exact same thing, except it's got a different type in here. And remember we asked you to do, we said that inside of your requirements here, here's for you to do torpedo polymorphism. So you're going to rework the torpedo classes so that there's a torpedo base class and 2 subclasses for two types of torpedoes, Torpedo Federation and Torpedo Klingon, 2 different classes, right? And let's think about how we would do this kind of thing. How would you make it so that there's like, we don't have to do this crazy vector stuff that's going on here? Well, there's a couple ways to do this, but this duplication is that. Okay, so that's number one. So that's one thing we added into our are placing.h. Placing.h needs a reference to a torpedo and some kind of torpedoes K, vector to keep track of the torpedoes when it comes to collision detection or anything else you want to do with them. Some hints. You could include collision detection, if you're going to do that, inside of each of the torpedoes, like we mentioned earlier. In this case, maybe it's not even necessary to have a torpedo vector here at all, right? So we can kind of save ourselves some memory and do the collision detection for each torpedo. We could do that. Or maybe you want, a generic torpedo, vector that holds all the torpedoes. We don't care which one, right? It's going to match all of them. Any torpedo that gets added in, it's going to be updated. Right now we have two different types, but they're very similar, right? So you can have one vector that handles all types of torpedoes, right? For collision detection purposes. Well, maybe that is the way we want to go. All right, so a couple of ways. We'll leave the details to you. And this is kind of new for Lab 8 as well. So this is new for Lab 8. All right, that's something we added in there. And this needs to go because it's the same as this one. Okay, so that's what we did. We also did this new for Lab 8. New for Lab 8. There we go. And okay, cool. We did that. Well, okay, awesome. Then let's start at the top and see what else we have to do. So at the top, we can see that we had a couple of examples here. We had for the close combat enemy, this stuff was kind of uncommented. But actually what we did last week was we left it at the ranged combat enemy. So the ranged combat enemy has all the stuff that we need right now to make it so that we have a distance check. I just can't spell. A distance check. We have a ranged combat enemy to make sure that we can detect the radius detection, so just outside of line of sight range. We make sure that we set up the detected. Also make sure that we check to see if the enemy's in range. All this stuff is set up so that we're ready to go. There's no changes for us to make with all of this. If you wanted to change it from the close combat enemy, you can just comment out the range combat enemy stuff and put back in the close combat enemy parts that I've labeled here for you guys, okay? But we don't have to do that, so we're good to go from this piece. Next, let's scroll down. So that's the first part. There's nothing for us to change up there. Okay, well, what about some additional things here? Let's modify some stuff that happens down here. We didn't have a chance to fill in my spawn enemy torpedo. How will the spawn enemy torpedo work? Well, let's also change this to Lab 8. So the way spawn enemy torpedo is going to work is, let's take a look at an example of what we already do. Well, up in our key press, we've made it so that when we press the F key, we spawn a Federation type of torpedo, the other one, right? Well, this code is very similar. Uh-oh, I just said it again. This code is very similar to the new code that I'm going to put in, which when we say that, if I copy paste, if I'm doing copy pasting, right? For you in your mind, that should be, well, that means that we have some refactoring to do, right? So let's put that in here. So this is what we got from the F key by pressing the F key. So this is where the torpedo is going to fire, but we need a couple of additional things for the torpedo to fire, okay? And because our torpedo firing mechanism is slightly different for a spawn enemy torpedo, we need to, well, set a spawn point. And Alex made it a point saying it should spawn from the front of the ship. Front of the D7 Klingon ship, right? So that's where it's going to go. So how do we do that? Let's say this set a GLM vec2 object, which will be the spawn point. We'll call it the spawn point, okay? And this spawn point is going to be equal to m_p spaceship. So wherever the spaceship is, we'll say get transform dot position. And we'll want to put it in front of the spaceship. So we'll say, let's add on to that vector, that position. Let's add on another vector. We can do vector addition here. And we can say that get current direction. So that's the direction vector that's in front of us, the way we're pointing. And then let's multiply that by some value. Alex suggested something like 30 pixels. So we'll add 30 pixels in front from the middle of the of the ship, because remember, all the ships, the current position, this is actually the center of the object. So take the center of the object and add 30 pixels, and in the forward direction, that's what this is. The current direction is the forward direction. Add 30 pixels, and that is the spawn point of the torpedo. Next, what we want to set is the direction. Let's set the direction of the torpedo. All right. So to set the direction, we need a couple things. We need to say that GLM vec2. Let's set the direction, right? And let's make it specific. So we'll say torpedo direction. And that torpedo direction is going to go where we want to fire it. We're going to say that that's going to be equal to m_p target, and we'll go get transform dot position minus my spawn point. Remember this when we did this minus in our graph? We said if we take this point B and subtract point A, we get this big line that goes from here to here, right? We don't want this big line. We only want this little part right here, which means we need to normalize this part, right? So we can just do a util normalize, and we want to util normalize this whole piece. Now, Alex did it differently in his part. He broke it up over 2 lines. That's fine too. But now this torpedo direction is a normalized value, which is a normalized or unit vector value. Okay, that's what that is. So we get the unit vector, that's the torpedo direction. We've got that down. And once we have the torpedo direction, then we want to spawn the torpedo. This is the next part. Spawn the torpedo. So how do we do that? Well, we want to first of all change this torpedoes to torpedoes K, because we know we want it to go right now anyway in the Klingon torpedo bank, if you will. Right? That's the memory bank for our Klingon torpedoes. Woohoo! And we don't want to just spawn any type of torpedo. It has to be a torpedo K. Okay, cool. I like that. And now that we've spawned a proper Klingon torpedo, nice, nice, we want to also put in there what is the torpedo direction. So that is the torpedo direction. That's where it's going to be firing at. Okay, so now we've generated a new torpedo, a new anonymous torpedo. We've added it to the torpedoes K vector, which is a managed array. And now we want to say, okay, we'll take that last one we added in and tell me what the position is going to be. Well, that's going to start where? The spawn point, right? We want it to start at the spawn point. That's where we want the torpedo to start. So place torpedo start at spawn point. Okay. And Sound Manager says we want to play a sound called torpedo. Yeah, we don't want to play that sound. We want to play torpedo K, which is, that's what we're going to name it, torpedo K. And torpedo K is going to play the torpedo sound, but we haven't mapped that yet. Let's do that up here. So up here where we have in our, this is inside of our start function. In our start function, we have a bunch of these sounds we've registered. Let's register another sound. And we'll register the torpedo underscore K sound, and it's going to be the torpedo underscore K.og, if I'm not wrong. Okay. And if I'm wrong, we'll know in a second. Alex also suggested we move away from playing the Mutara music, which he likes, and happy sounds, when we fight the Reliant versus the Enterprise, to using the Klingon sounds, which I agree. I think it's a Klingon fight right now. Klingon versus Federation. Excellent. So we've got those sounds changed. Let's go back and see if there's anything else for us to do. Well, we added a torpedo to the scene with an add child, and we're pushing it back. We're getting it from the torpedoes K location. That's where we're getting it from. And my friends, that should be everything we need. I don't think there's anything else that I missed. Maybe I did. We'll see in a second. But that's really it. That's spawn torpedo. All right, let's try this out and see if it works. And those are the only things we modified. We didn't really do any changes up here, right? So this is something we already had going on, so we didn't have to do anything in our case. for other people who are watching, in order for you to change this, make sure that you've turned on set is hit, right? We want to make sure that that is true. We also want to make sure that set detected, if the enemy's been detected, as well as set is within combat range, right? Because if it's within combat range, then we want to, once we set this as true, then the ranged combat node is going to make it so that we can fire. That's what's going to happen. Okay, so this is important for it to be turned on. All right, let's try this out and see if it works now. We should see the Klingon cruiser, which is a old style D7. One day when it feels like compiling. Yay! There it is. And let's bring up IMGUI. You can see that we have the player is within our radius. Radius is quite large, so the player's been detected. If I toggle the grid on, right, you can see that there it is. You can see that the player's been there. And if we move our Klingon vessel, right, over to the right a little bit so it has line of sight, it should fire. So let's do that. So we'll say move the ship over. And as soon as we get line of sight, I'm just moving it slowly. As soon as I get line of sight, then, hey, right, we get firing. Okay, pretty cool. But you know what would be really great? If not only it fired, but it also angled so it looked like it was firing in the direction it's looking. That'd be nice if we had that. Right. We don't have that yet. So let's that is what we want, but it's not part of our lab. This is something that I'm thinking up over the top of my head, right, to add in. But let's do this first part. So we've accomplished our lab. Our lab for the most part is completed, right? Let's do a message. We'll say something like we updated the placing to include a spawn enemy torpedo. And once we've done that, it was able to fire and all that stuff, all that good stuff has happened. So we'll do that, and that's our update. And now, for the most part, if you look at Alex's notes, then we've done all the way down to here. Okay, this stuff is all complete. However, I want to point out a couple things. So for you to do, one is do these two torpedo classes, Torpedo Federation, Torpedo Klingon. How would you go about doing this, right? So again, what we talked about, make a base class. What are the similarities that you can see, right? Where I can make a torpedo class. What do I have in both torpedoes that are the same? Take those things and make a torpedo superclass. Okay, cool. What specializations now do you need that only the torpedo for the Federation has and only the torpedo for the Klingon has? What is the difference between these two things? You could have several things like damage, range, the type of what it sounds like. All that stuff could be here, okay, inside these two classes. So far, what we've done inside of our play scene is we've registered the sounds right here, right? That's what we've done, and that's okay. But you can definitely play these sounds, play this stuff inside of the torpedo itself when it's firing. So each torpedo makes its own sound, as opposed to making a sound, by the spawn enemy torpedo class, right, or function. So you can do that. You can also make it so that there's only one type of, when we make this, we use polymorphism or inheritance to create two different types of torpedoes from a base class, right? Then, like it says here, we want one vector of torpedo pointers, which is the base class. We've done this before, for sure. And for collision testing, you can choose dynamic cast to test which subclass is actually pointed to by the torpedo. Nice, right? And you don't actually have to do collision for this. It's more of an FYI, and that's why he thinks you should do a commit and try this out. I think it's a really nice exercise, guys. Very simple to do. Yeah, I'll do that one second, Ethan. Hold on a second. The other thing is you're also going to have to do a move to player action. How do we do that? You fill in the move to player functionality for the close combat enemy. So this is the close combat enemy side. You need to uncomment out the close combat enemy stuff in your placing in order for you to test this out. Okay, and the enemy must actually seek or actually arrive at the target and then change to an empty attack action. Okay, but how does it do that? There are a lot of things you can do to make that happen. Are you going to be able to pass through obstacles? That is the question you should ask yourself. And the answer for you should be no. You shouldn't be able to pass through any obstacles, which means that those path nodes that we turn off when we're running the game, right? We run the game. And when we do path nodes, let's look at those path nodes. Like we said, these path nodes have been turned off for all the obstacles, right? All these obstacles have path nodes. And we've given you this obstacle buffer that you can implement. So you can change how many, what path nodes are available, right, to traverse, right, around here. So you can't target path nodes that are turned off, so to speak. That might be a strategy for you, right? So sure, I want to seek the nearest path node that has line of sight. Well, it's not going to be this one because there's no way to get there from here. You can't go across this cloud. It's not available, right? You need to go from one path node to the other, right? And that can present a challenge. How do we do that? We can use pathfinding. You can use other strategies, right? But that's one of your challenges for assignment 4. How do I go towards the player without moving through the obstacles? Because the obstacles are there for a reason. Yeah. Okay, so think about that one. Let's also go back and handle Ethan's question, which is the build tree function for the range enemy. Okay, sure. Let's take a look at that real quick. So if I go to the range combat enemy and the build tree action, build tree, it's way down here. Here it is. Which part did you want to look at? It's pretty big. I think this is all of it though. The attack part never starts. It will if you move it into enemy. When it got line of sight, that it should work automatically. So that's what happened to me. I thought it wasn't working, but actually it does. So the way to test this is if you bring up I am GUI, let's put this down over here for now, right? So here's I am GUI. And if you bring up the grid, right? And if you notice here, this is the ship, right? But if I move this ship closer, this one over here, right now, notice it says performing move to line of sight. Move to line of sight, let's do it for the ship. So we'll move it, the x-axis, we'll move it over to the ship until it has line of sight. Notice how on the left, it has move to line of sight. Take a look at that. So if I move it over, right, it doesn't span. It just sits there, right? Move to range means it's too close, right? That means either it's too close. So if I was too close, look, if I'm too close, like this close, then it's going to move to range action. It has to be at the right range, which is far enough away that it can move to do the attack action. Take a look at my code as well. Where is the range set? So, okay. So remember that we set the range action, right? Let's take a look at the constructor function. So the constructor function is where we set a couple of things here. We set line of sight distance, right? And we set a bunch of stuff up here in terms of where things are going to be set. And this is where it's done in the constructor function, but in the placing.cpp and over here, these are a lot of these values are set right here. So for example, range combat enemy, if the player is detected, so that is the radius condition. If the distance, which we calculated here, is less than 450 pixels, then the enemy has been detected. That's the target, right? And if it's between, here's the in range. If it's between 200 pixels and 350 pixels, so not too close and not too far, then it's considered in range. It's inside of the play scene. Okay? Should be the same as mine. And you can play with these values, try these values, change these values around. see what it looks like. Okay, but I've got another thought before I let you guys go. We still have a lot of time to talk, right? So yes, this is true. We can make this work, but it looks pretty ugly, doesn't it? I mean, if the ship flies around and we turn on the grid and I move the ship around to here, and then it kind of fires from the side or even from behind itself. Look, like if I go down here and it's down here, it fires like from the top, like this way, right? And well, typically ships don't fire that way, right? Typically what happens is if I have a ship, and let's suppose, I'm just going to draw it out here. So let's suppose I have a ship that looks like this. And let's say this is B, and the ship is pointing, well, let's say it's pointing this way. So here's the ship. Yeah. Here, yeah, there's the ship. If the ship is pointing this way, it can't typically fire over here. It has a lot of times something called the firing arc, right? So the firing arc might be something like 30 degrees, right? Or 60 degrees, whatever the firing arc is of that weapon. So this firing arc is where it can fire. If the object is over here, well, it can't fire over here. It's got to look where it's firing, kind of thing. Almost like, hey, look where it's going. Right? So it'd be nice if the ship was turned toward where it's firing at. And you may want to implement that because we asked you to do look where you're going anyway. You may want to implement this inside of your A4. Well, what can we do to do some of this right now? Can't do it all, but maybe some of this can be done. So where can it be done? So let's go into our ranged combat enemy again. By the way, I showed you the wrong enemy. Here's our ranged combat enemy. Right? So we can see that these are the actions, right? And we have move to cover and wait behind cover and all this kind of stuff. Move to line of sight. Oh, move to line of sight. It can be done there. Let's think about this. To move to line of sight, what are the actions you need? Here's some pseudocode. You need to, move to the closest node, right? And again, here's a condition, without moving through an obstacle. And this can be accomplished by pathfinding. That's one way of doing it. You could do it through steering behaviors. Okay, but that's the one thing you want to do, right? So move to the closest node with line of sight. With line of sight, right? To the target without moving through an obstacle. You can do that through these two things. So that's the first thing you do. You kind of move there. Okay, good. And when you get there, you switch out of move to line of sight to the attack action, which is something we've covered here to some degree, right? There's your attack action. Okay, cool. Well, this is nice, but before we fire a bullet, don't we want to turn to face the attacker or the target? So let's do something like that here. Here's optional for lab 8. It's not really something you need to do, but we should, turn to face the target. Okay, how do we do that? We have methods to do this already for us, don't we? We have something called look where you're going. So let's try this. Look where you're going. And what it needs is look where you're going requires a target direction. Well, we know where the target is, right? So we can say that our target direction, well, that equals to the target, right? Get target. So we have get current target, but we also have get target, right? So that's the get target position. We know that. That's the get target position, right? That's where the target is, minus our current position, get transform dot position. We know that's the thing, but we need to normalize this as the target direction. So we need to do a util normalize, right, to the target direction. That is something that is the normalized target direction. And we can put that in here, right? Look where you're going. And if we did that, maybe, right, I'm just saying, maybe that this will turn in the direction we're looking. Okay? Well, let's see what actually happens. That's probably not what's going to happen. All right, let's try this out and see what happens. We might have some wacky effects. So, okay, cool. Let's move him to line of sight. So he's within line of sight now. And, oh man, he's turned completely around. What the hell? He worked in the exact opposite of what we thought he was going to do. Well, why? Let's take a look what's happening and look where you're going. Go to definition. Look where you're going says take a target direction, right? Cool. And once we have that target rotation is the difference between the current direction and our target direction. Okay, good. Minus 90. Huh? We did this for a reason last time, but if we remove this for now, and this is from the look where you're going for the ranged combat enemy. I'm not saying this is the right thing to do. I'm telling you this is maybe a fix, you know. There's a lot of code here you may not even need, right? You could also use some of this code because of the whiskers to use collision avoidance. Hey, that's also something you can do using the collision avoidance thing that we taught you how to do in first half of semester instead of doing pathfinding, right? I got to put that in there. And then if I run it, we should be able to, you know, do what we did before, which is if I kind of move this thing over, then we should be able to change the, but what happened? Did it move? What the heck? How come it didn't do it? Right? Why didn't it do that thing that it's supposed to do? Well, did we ever in the scene, did we ever set the current position anywhere? Maybe not. And it only set it once. So what we need to do is we need to set it all the time. So something like we want to, hey, M underscore, this is optional for lab 8. We can say M underscore P spaceship, and we want to set the target position to whatever the M underscore P target is. Maybe that's going to help, right? Dot get transform dot position. Get transform. Oh, get transform, I said. Dot position, right? So we want that. We want to set the target every frame because if the ship is moving, then the target should, well, it's a different position potentially. Let's see if that helps. So, or not, right? Maybe that's not going to help at all. But the idea is, oh, look, it's already moved. So the idea is the same, right? So if I move my ship now to the position, then, there we go, right? And you can see that that works okay. And if I move my ship around, but this causes other issues, by the way, right? So if I move over here, you can see I'm out of arc, right? But it's going to try and swivel where I am, right? And the problem with this is it'll actually go through the target. Look, it'll actually go through, right? It'll go through even the obstacles when I did that, right? So that causes other issues, other side effects. I love it. So that's pretty cool, right? And if I get out of range, it'll kind of like try and get closer to me by going through these obstacles. Crazy, right? Why? Because I'm looking where I'm going, and that's not what we want. It's going to go in the direction that I want it to go into. And so look where you're going has actually a detrimental effect, at least in this case, because if I only want to do it once, then what if I'm already pointing at the target? I don't want to do it every single time, right? That's the way. So again, some ideas about what you could do. This is clearly wrong, all right? But the idea is okay, right? And let's see if I move this. Let's move this ship here manually. Let's move it around over here. Let's see what it's going to do now. Well, instead of doing its patrol, it's not patrolling anymore. Why? Because I told it to look where you're going. And, well, that's always going to be the case, right? Because I've given it the target direction. But the target direction, there's two target directions, right? The target direction should be the next point, right? In its path. That's where it should be. So let's go back to that. I want to talk about this for a second, right? So yes, it's awesome. We did what we did so it can fire in the right direction. And this is a neat idea. But what it does is it overrides what we told it to do up here in its patrol. We said the patrol path, we push back a patrol path, right? And we set up here the target position is the next waypoint in the patrol path. Oh man, but that's why it's pointing where it's supposed to point. It's pointing in the next position because, well, that is not what we want. So definitely we're using look where you're going, but look where you're going, well, that isn't exactly what we want to do, right? So maybe we can take some of those same things for look where you're going and put it inside of our action, right? Our attack action. So look where we're going, nice idea, right? As an example, yes, I want to do something like this, right? I want to do something like this idea, but I, well, want to keep it different than this. So how do I do that? So up here, let's put that -90 back into look where you're going, because we need that to properly rotate things for our scene. And we don't want to do that in the playscene.cpp. This part right here, which is nice, is, well, it's great, but that is for the next target, like the next, instead of target position, it's almost like I want to have the next waypoint. That's where I want to get to. That's what we're doing here in our ranged combat enemy. Our ranged combat enemy's got these waypoints to patrol, and we're using that target position as the waypoint that I want to get to. So how do I rotate towards the actual target, right? We could have another method we could use if we really want to, like rotate towards target, or whatever. But we need something like that, where we do some of the similar things. We don't know what the target position is, but don't we have access to that in the scene? That's also a hint. Look, we know we're getting access to the play scene, right? And again, I'm just exploring this stuff with you. We know we have access to the play scene. And so maybe in the attack action, which is down in here, well, we know we have access to the play scene, which is right here. Maybe we get access to the play scene a little bit earlier, like up here. So, okay, cool. We'll say auto. We'll say that the scene itself that we want, we'll call it the scene, is the scene we want is equal to this dynamic cast play scenes, this thing right here, this part. Yeah, that's the one we want, right? So we want to say that the scene, this scene right here, whatever the scene is that we're the data we're holding the scene information here, so we don't have to dynamic cast anything over and over again. That's the first thing. So scene. And then we can just simply say scene down here, right? So you can kind of do that, right? And that's going to help us with our enemy torpedo and blah, blah, blah. Scene dynamically cast. Cool. All right. That's nice. But then can't we also get scene as in like the scene target? Isn't that possible? Right? Because we have access to that too. What's in the playscene.h? What is, private and what is public, right? We have information in the play scene that is public, and we have stuff that's private. We have a reference to the scene class itself, but the scene class, the scene objects, the pointer to the scene class only includes or exposes elements that are public, not private, right? So if we want to be sneaky, I'm just saying, right? Want to be sneaky for a second, we could move this temporarily, right? That's to put it up here, right? I mean, it's not really named properly and all that kind of stuff, but I mean, we could do this. We could definitely do something like this, or make a getter. That'd be the other smarter thing to do. Some kind of getter that exposes the target right outside the scene, if you really want to. And then once I have that information, well, then I could rotate towards that. I can make another function to do that for me too, right? There's lots of ways we could do the same thing, but we need this target, not the path nodes. That's the target that we're using right now in our patrol, right? So lots of ways to solve this same issue. So let's make a get target. So I'll make a target, which is the target pointer. We'll call this get target. And just for simplicity's sake, we'll just have it here for now, just so we don't do too many changes here, because again, this is just optional stuff we're setting up, and this may not even work, and I'm just randomly doing stuff with you guys just to play. And we'll say return m_p target. So that is the way we can do that right here, right? And when we return the target, get target is actually going to return target. It probably needs to be const, of course it does, because it's going to return a reference to the target object itself, which is this one right here. And now if we did that, then couldn't we go into the playscene or the RangedCombatEnemy.cpp, and because we have reference to the scene, well, we know what that is, right? The target position isn't the target direction anymore. The target position is, well, that would be not what we're looking for, right? That's not what we're looking for. What we're looking for is the, instead of the target position, we need to go to, hey, scene, I want you to get the target position. And I want to get that get transformed target position from the scene, which is where it is right now. And whatever that is, I want to normalize it, and that is the target direction. Now let's see if we can do look where you're going into the target direction. Let's see if that computes in any way. It may not, but let's see what happens, right? And let's run this thing and see what happens. And maybe it's we're false, we're wrong, we didn't do things the right way, right? But that's okay, because we're playing around and we're trying to explore stuff, and exploring is where we get a lot of really cool, you know, kind of great learnings, right? So, okay, cool. Let's move this over here to inline of sight. And man, almost. It's looking, but not quite. And if I move my ship around my target, then it should now patrol as normal. It's patrolling as normal, so it's not going to kind of turn where it's supposed to. It's almost there, almost there. Well, we're only like a minus 90 away, right, from where it's supposed to be, because look where you're going is actually going to take that target direction, right? And the target direction is going to be the that normalized direction. It'd be nice if I can do the look where you're going with some kind of not adding 90 to it. Let's go to definition for this one. There it is. Look where you're going actually has a target direction. And we can say, do we want to have an offset, right? Whatever that offset is. And we could add an offset or not, right? So let's put that as something we want. We can put it in a float, which is an offset, and call it an offset, which we're going to set to some value in a second. Now the float offset is what I want to put here, right? This minus 90. But look where you're going right now in the ranged combat enemy. If I go back to RangedCombatEnemy.h, look where you're going does not offer that option, right? So let's put the option here. So float offset, whatever that offset is, and we'll set that offset to minus 90. Minus 90. So we set something for it right away. So unless otherwise specified, the offset is minus 90. That's what we're saying here. Cool. So if I go back to the ranged combat enemy and I just use offset here, right, then we could, well, let's actually do something else. Let's not make it a minus. Let's make it 90, right? There we go. And then we just make this so it's minus offset. There we go. Same effect. We can also make this a const, right? Make it a const. There we go. That's what it's asking for us to do. Awesome. That's great. Nice and easy. And now that we have this little change-o-matic to the scene, right? Yes, we can. We can definitely do that. For sure, Ethan. One sec. And then this is great. Then what I can do is I can go back to the our stuff that we were working on over here and say, look where you're going, the target direction without an offset. My offset's going to be 0. And that kind of makes it so that look where you're going now is going to be more flexible than what it was before. I'm cheating. I know I'm cheating. But hey, what the heck? I'm going to do whatever I have to do to make my effect the way I want it, which is, guys, what you should be doing for your A4. Make it so that your A4 does what it's supposed to do, right? Let's try this out and see what happens. Maybe this is not even going to work, right? You never know, right? Well, we know we kind of tested it and it kind of worked. So it's most likely it's going to work, but hey, let's see what happens. So this is cool. And again, I'll pull this up, toggle it on, and let's move this guy over again. And hey, look at that. He turned now to me. But if I run away, I'm running away, he's going to go back to seek where the target is. And he's going to seek around back to where he was before, you know, as an example, until he's able to get me in his sights, right? You can see as he's moving, these areas here have line of sight. The closest thing to line of sight when he gets within range. He hasn't detected me right now, or he's out of range, is here. So what's the closest point that has line of sight? Probably one of these things. Look, 1, 2, 3, 4, you know, or 1, 2, 3. Maybe this one has line of sight. Let's move him up there. So we'll go back or up a little bit, and we'll move him up there to where he's supposed to go. And okay, we have line of sight, but he's not firing. What's going on? It says range action, move to range. He's too far away still. So even though he's got line of sight, he's out of range. Okay, so cool. Let's move him into range. So let's move this guy to the, oh, not that guy. There we go. Now he's in range. And he's going to fire in the direction he's looking. Right? So a modification for Lab 8, it's optional, right? So that's why I put optional for Lab 8, where I want to make the, you know, the enemy fire in the direction that he's looking. It's not that difficult to do. Again, we had some tricks that we used to make that happen without modifying too much, because otherwise I would have to change this whole patrol path thing. We didn't want to change that because that was a pretty cool idea that Alex had. Leave it alone, but we did modify the scene where I exposed my target. That's definitely one way of doing it. Is it the only way of doing it? Hell no. There's lots of other ways, maybe better ways than this one, but it at least accomplishes the thing there for you guys. All right, any questions around this insanity? Let's put this up on GitHub. We'll say this is the Lab 8 modification. We'll say added or enabled enemy to look at target when firing. So we did commit all and push. So you can see those changes too. All right, any questions around this before we stop recording for the day? Okay, guys, that's it for this lab. I'm hoping that this is good. This will help you with your assignment 4. That's what these labs are all about, helping you think. Please make sure, in order for you to get full marks for what you're doing with your lab, please make sure you follow the instructions that Alex has given you, as well as things that you need to do yourself, which is this part right here. This is for you to do, okay? And I think it's important for you to follow these directions and think about how you can do these things, right? How will I move my player to my too close to the target? How do I do that without going through the targets themselves? I could use whiskers. I could do a lot of stuff. I can enable all the things we already gave you to do, right? As opposed to the things that you already have. There's things that you can do to improve this. Okay, so take a look at these. And that's really it. Okay, one more thing before we go, a bit of administration. Again, things to note is assignment 4, right? Assignment 4 is due this Sunday at midnight. Is it? Is it due this Sunday at midnight, or did we make it some other time? Did we move this date, guys? Hold on a second. Is it due this Sunday at midnight? Assignments. Oh, that's bad. Oh, that's bad. It can't be due Sunday. We're going to have to move this to Monday, guys. I'm so sorry. I'm going to have to move it to Monday. I can't make it due on Easter Sunday. That's a negative. Let's move this out. So that is a change we're going to make right now. That was an oversight on my part. So April 18th, it's going to be. So we'll say due date moved, due date changed, right? And yeah, that's going to definitely be something we're going to have to do, because we can't make it due that day. That's not fair. I'm not going to be available during that day. I'm going to be enjoying, Easter with my family. I'm sure you guys want to enjoy Easter with your family. So, or for some of you anyway. And for those people who don't, well, then other people are getting it, but not you. That's not fair. So due date change to April 18th is what's going to happen. And I'm just going to move this due date to the 18th, which is Monday. Monday is, we're open, right? And that means we'll keep this the same. Yeah, we're going to have to keep this the same. We have no choice but to make this the same. So that is the due date because it'll give you an extra day. And the reason for it is because we need to present on the Thursday. So you have to have everything ready by the Wednesday. All right, so that's why we're doing that. Submit. Yeah. So that is a change. Administratively, this is, we'll say due date changed. Due date changed in the video, right, to next Monday. So next Monday, that's April 18th, right, at midnight. So please make sure that you know that. It gives you an extra day, but we need to give you the extra day because it's not fair. So let's make sure. I didn't even realize that, guys. No one even said anything. So there it is. Okay. So that's something we need to do. Also, make sure that assignment 5, which is your presentation, we're going to release a list for you guys early in the week, Monday, where we're going to release a sign-up sheet for you to do your presentations during lab hours on Thursday. And so the Thursday, we're going to have each group present, right? And you need to present live in order for you to get full marks. Okay, just letting you know. So that's happening on Thursday. So we're going to make a list that comes out on Monday for you to sign up. So please make sure you do that. Okay, and that's it for me. I'm going to stop recording now. I know we went over time, but we'll see you guys next week. Good luck and have a good time on during the weekend. Take some time off. I know I will be. And then we'll see you guys next week. All right.